Okay, so let's look at the second example. We have 500 equals 25 times 3 to the exponent x. And so what I'm going to try to do again is to try to solve for the exponent part. And what I'll notice is that I have a coefficient of 25 multiplying with the exponent part that I have here, 3 to the exponent x. And so I can actually eliminate this 25 by dividing both sides by 25 first. And what I end up with is 500 divided by 25 is 20. So I have 20 is equal to 3 to the exponent x. Now again, I have two different bases, and I don't have any way of writing 20 as a base of 3. So I know this is going to give me a decimal answer for x. And again, I can sit there and do trial and error and try to figure out 3 to what exponent will give me a result of 20. Or I can take the log of both sides to try to solve for the exponent. So that's what I'm going to do. I'm going to look at the log of 20 and the log of 3 to the exponent x. And again, I can use the power law of logarithms. The answer part here has an exponent. I'm going to rewrite it as a coefficient. And I get log of 20 equals x times the log of 3. Okay, and if I divide both sides by log of 3 again, much like what we did in the last example, the log 3 part cancels out. On the right hand side I'm left with x, and I can calculate the rest of it on my calculator. So log of 20 divided by the log of 3 gives me a result of about 2.73. And if I check my work, I'm sure it's correct. Okay? And so this leads to something called the change of base formula. And to calculate a logarithm with any base, we can express the logarithm in terms of common logarithms, which is essentially what we did here. Okay? We could have looked at this slightly differently. We could have said, well, because I have 2 equals 1.5 to the exponent x, I could have also written this as log of 1.5, log base 1.5 of 2 is equal to x. So I could have also looked at the question like this, okay? And now in this case, you'll notice that the base and the answer are very difficult to rewrite with the same base value. And so in exponential form, it makes it a little bit easier, and we took the log of both sides. We're actually going to see how to go directly from this form of a logarithm to this form of the logarithm here, where we did log of 2 divided by log of 1.5. And hopefully you'll notice that when we were evaluating here, all we really did is we took the log of the answer, so the answer part was 2, the base part was 1.5. To solve for x, all we did is we took the log of the answer and we divided it by the log of the base. And we did the exact same thing here as well. We had 20 equals 3 to the exponent x, and we took the log of the answer, which is 20, divided it by the log of the base, which is 3, and we got the answer for x. And so that's essentially what the change of base formula introduces. And so to evaluate a logarithm whose base is not 10, we can use a change of base formula. So if you have log base b of m, you can evaluate this using common logarithms and rewrite this as log of the answer and divided by the log of the base. Okay, again, the same conditions apply. The answer part has to be greater than 0, the base has to be greater than 0, and the base cannot equal 1. Okay, so we're going to look at another example. So here it says evaluate and round all answers to the nearest hundredth. And so I have log base 5 of 100. Now I can sit there and try to figure out 5 to what exponent will give me 100. Or I can use a change of base formula and rewrite this as the log of the answer divided by the log of the base. And because we're looking at common logarithms, when we've rewritten this, we can use our calculator to help us evaluate. So the log of 100 divided by the log of 5 gives me a result of 2.86. And I can check my work, because what this actually means is 5 to the exponent 2.86 should equal 100. And if I check that on the calculator, I should get a rough estimate of an answer of 100. So 5 to the exponent 2.86, and I get about 99.78, which is about 100. Okay, so it's not exactly 100 because we rounded off our answer in the first place. So this is approximately 2.86 as my answer. Same idea for the next one. So log base 3 of 75 is the same thing as writing log of 75 divided by the log of 3. And again, I'll use my calculator to help me evaluate that. And I get about 3.93 approximately. Okay, the last one's slightly different. I'm looking at log base 4 of 18 to the exponent 2. Now, because the answer part has an exponent of 2, I can rewrite that as the coefficient of the logarithm. So this would be the same as writing 2 log base 4 of 18. So there's the power law of logarithms. Now I can also use the change of base formula to evaluate the logarithm part that I have here. So the 2 is still the coefficient, but I'm going to rewrite this as log of 18 divided by the log of 4. And I can do all of this in one step on my calculator since the operations are just multiplication and division. And I have 2 times the log of 18 divided by the log of 4. And I get an answer of about 4.17.